I choose it as an even T, so number of elements in E which is favorable to the condition at most 2 hits is 7. So therefore, probability of E will be equal to 7 by 8. If I choose a student who is studying mathematics, then the probability of the student who is studying mathematics is given, that is 40%, which can be written as 40 by 100. When the probability of A intersection B is more than the value of the given set, then obviously it is not consistently defined. Hello everyone, a warm welcome to one and all. This is Shruti ma'am, Department of Mathematics. Today in this session, we are going to take a few more problems to calculate the probability. So in this session, we are going to take some practical problems on probability. So if E and F are even such that probability of E is 1 by 4, probability of F is 1 by 2 and probability of E and F is 1 by 8, find probability of E or F and probability of not E and not F. So we know that E and F is nothing but E intersection F, E or F is nothing but E union F, and not E is nothing but A dash, and is nothing but intersection, not F is nothing but F dash. So instead of A dash, you have to write here E dash because we have used the letter E. So it's E dash. Now first let us calculate probability of E union F. So we have a formula, E union F is equal to P of F, E P of F minus P of E intersection F. And here probability of E is given as 1 by 4, F is 1 by 2, E and F is 1 by 8. So by taking the LCM here, we'll get 8. So next is 4 2s are, 2 4s are, 8 1s are. So 6 minus 1, which is 5 by 8. So probability of E union F is 5 by 8 here. So next we need to calculate the probability of not E and not F. So from the De Morgan's law, we know that A union B whole dash can be written as A dash intersection B dash. So here we have E dash intersection F dash. Hence, I can take it in the form of probability of E union B whole dash. Again, from the probability, we know that probability of any complement is always 1 minus probability of the given set. So it is E union F here. So next, we have calculated probability of E union F as 5 by 8 here. So it is 1 minus 5 by 8, which is equal to 3 by 8. Next question. A and B are even such that P of A is 0.42, P of B is 0.48 and P of A and B is 0.16. Determine probability of not A, probability of not B and probability of A or B. So from the first, probability of not A is nothing but P of A dash, which can be written as 1 minus P of A. The probability of value of A is given, that is 0.42, which is equal to 0.58. Next, we need probability of not B, which is B dash. So it is 1 minus P of B. 1 minus 0.48, 0.52. Next, C, probability of A or B. So A union B, which is P of A plus P of B minus P of A intersection B. So which is 0.42 plus 0.48 minus 0.16. So solving this will get the value 0.74. Next question. A letter is chosen at random from the word assassination. Find the probability that the letter is a vowel, a consonant. First, count the number of letters in the word assassination. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So therefore, total number of letters is 13. That is N is equal to 13. Among them, we need to count number of vowels. So that is 1, 2, 3, 4, 5, 6. So there are 6 vowels. Obviously, the remaining 7 has to be consonant. Now, if I take a vowel as the probability of getting vowel, that means I need to choose a letter so that it is a vowel is 6 by 13. And similarly, probability of getting a consonant is equal to 7 by 30. Next question. 3 coins are tossed once. Find the probability of getting 3 heads, 2 heads, at least 2 heads. So the sample space contains 8. So that means the sample space of this experiment is H, 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 T, H, T, H, T, H, H, T, T, H, T, H, T, H, T, 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 T. So there are 8 outcomes for this experiment. So if I choose this as event A, so probability of getting 3 heads is only 1 outcome. So that means number of favorable outcome is 1 and the total outcome is 8. So therefore probability of A is 1 by 8. Now if I choose this as an event B, getting 2 heads, so there are HHH, HTH and THH. So therefore N of B is equal to 3. So there are 3 outcomes. So therefore probability of getting 2 heads will be 3 by 8. Next, at least 2 heads. So at least 2 heads means the outcomes which contains 2 heads. So we have this also, it has at least 2 heads. Among them we have 1, 2, 3, 4 outcomes. The rest of them have only 1 or no heads. So therefore the possibility of getting at least 2 heads is 4 and hence the probability of getting at least 2 heads will be 4 by 8 which is equal to 1 by 2. So similarly for the same experiment, if 3 coins are tossed once, find the probability of getting at most 2 heads, no head, 3 tails. So here at most 2 heads means, so maximum it can contain 2 heads. So that means it is less than or equal to 2. So we have an outcome here, except this outcome, all the other outcomes have at most 2 heads. So therefore here, if I take or if I choose it as an event E, so number of elements in E which is favorable to the condition at most 2 heads is 7. So therefore, probability of E will be equal to 7 by 8. And when I say no head, the only possibilities is getting 3 tails. So therefore, if I choose F as an event, the number of favorable outcome is 1. So therefore, probability of F will be 1 by 8. So no head is nothing but getting 3 tails. So therefore, probability of, if I take this as getting 3 tails, if I choose it as an event G, then this is also 1 by 8. So next question. In a class 11 of a school, 40% of the student study mathematics, 30% study biology, 10% of the class both mathematics and biology. If a student is selected at random from the class, find the probability that he will be studying mathematics or biology. If I choose a student who is studying mathematics, then the probability of the student who is studying mathematics is given, that is 40%, which can be written as 40 by 100. Similarly, the student who chooses or who study biology is also given, that is 30%. And among them, 10% study both the subject. So that means it is M intersection B. So it is 10 by 100. So we need to calculate how many students will study one of the subject. So therefore again this is probability of M union B is equal to probability of A, probability of B minus probability of A intersection B formula. So hence this can be written as probability of M plus probability of B minus probability of M intersection B. So instead of A and B we have mathematics and biology. So which can be written as 40 by 100, 30 by 100 minus 10 by 100. So which is equal to 40 plus 30 is 70, 70 minus 10 is 60 by 100. So which means 60% of the students will be studying mathematics or biology. Next one, the probability that a student will pass the final examination in both English and Hindi is 0.5. The probability of passing neither is 0.1. If the probability of passing the English examination is 0.75, what is the probability of passing the Hindi examination? So, the probability that a student will pass the final examination in both subjects is 0.5. That is, probability of English and Hindi is 0.5. Passing neither means he will neither pass English and neither pass Hindi. So that is given as 0.1. Next, probability of passing in English examination is given, that is 0.75. We need to calculate the probability of passing in Hindi examination. So we have E intersection H, E and H, but we don't have E union H. So to calculate this, we'll use this concept, that is probability of E dash intersection H dash is 0.1. So this is a complement of E union H. So, or this can be written in the form of probability of E union H whole dash. And E union H whole dash can be written as 1 minus P of E union H. Now they have given the value of this, that is E union H whole dash, that is 0.1. So therefore, probability of E union H is 1 minus 0.1, which is 0.9. So using the formula probability of E union H, we can write this as probability of E plus probability of H minus probability of E intersection H. The value of this is 0.9, 0.75 plus probability of H is unknown and this is 0.5. So solving this, we'll get probability of H as 0.65. Events E and F are such that probability of not E or not F is equal to 0.25. State whether E and F are mutually exclusive. To show that two events are mutually exclusive, we need to show that they are disjoint sets. So first they have given probability of not E or not F. Or is nothing but union, not F is F dash. So again using De Morgan's law, E dash union F dash can be written as E intersection F whole dash. And here probability of E intersection F whole dash can be complement to probability of E intersection F. So here we have 0.25. Solving this, we are getting probability of E intersection F is equal to 0.75. This is not equal to 0. If E and F are disjoint, then their probability value should be equal to 0. But here we are getting the value as 0.75. So therefore, we can conclude E and F are not mutually exclusive events. Next one, check whether the following probabilities P of A and P of B are consistently defined. P of A is equal to 0.5, P of B is equal to 0.7, P of A intersection B is equal to 0.6. So here you can clearly see the value of probability of A intersection B is greater than P of A and the same thing is less than P of B. So clearly we can say it is not consistently defined. Next one, probability of A, probability of B and probability of A union B is given. So we need to compare the probability of A intersection B with both sets. So first let us find out probability of A intersection B. So we have A union B as P of A plus P of B minus P of A intersection B. So from this 0.8, 0.5, 0.4 minus probability of A intersection B. So this implies probability of A intersection B is equal to 0.9. So which means here probability of A intersection B is less than P of A. Also probability of A intersection B is less than P of B. So here we can clearly say that this is consistently defined. So when the probability of A intersection B is more than the value of the given set, then obviously it is not consistently defined. Next question, a committee of 2 persons is selected from 2 men and 2 women. What is the probability that the committee will have no men, 1 man and 2 men? So here we can clearly see a committee of 2 persons is selected from 2 men and 2 women. So here there are 2 men and 2 women, but I need to choose only 2 persons who may be 2 women, 2 men or 1 man and 1 woman. So therefore, for the first one, total there are 4 persons. Among them I need to choose 2. So therefore, the total probability is 4C2. Now among them there are 2 men. So if I have to choose no men, then the only possibilities is there should be 2 women. So therefore here, if I have to consider this as an event A, then this is probability of choosing 2 women out of 2 women with the total person. So this is 1 divided by 4 into 3 by 2 into 1. So which can be 1 by 6. Next is, if I choose it as an event B, that is probability of choosing 1 man and 1 woman. So then it is 2C1 into 2C1 divided by 4C2. So which is 2 into 2 divided by 4 into 3 by 2 into 1. So here we can cancel this. We'll get the value as 2 by 3. Next one, 2 men. Obviously, choosing 2 men is nothing but we are not choosing women. So therefore, it is probability of C choosing 2 men out of 2 men with 4C2, whose value will be equal to 1 by 6 again. Next one, there are 4 men and 6 women on the city council. If one council member is selected from a committee at random, how likely is it that it is a woman? So we have 4 men and 6 women, but we need to choose only one, and we have to find the probability that it has to be women. The total number of persons will be equal to 10. So n is equal to 10. Now if I choose probability of selecting a person which is women, 6 women out of 10. So therefore this is equal to 3 by 5. So thus in this session we have calculated some practical problems on the probability. So this is the end of the chapter 16 as well as your syllabus. I'll meet you in the next session with a new concept. Until then, keep watching, keep learning and keep exploring. Thank you.